Hello, welcome back. Today we will be learning how to identify the domain and range of functions. We are in Unit 2. We have talked a little bit about domain and range, but we are going to go a little bit further with that today. So we're still in functions and linear equations. Today we want to be able to identify the domain of both discrete and continuous functions. And then your essential question is, how do I identify the domain and range of both discrete and continuous functions? Feel free to pause the video and write all that down if you need to. All right, well, first we need to understand what the difference is between discrete and continuous functions. So a discrete function is a graph that consists of distinct points. Okay, they're not connected. Where a continuous function is a graph that is connected. So we create a line. All right, so the first one we are going to look at is just the domain and range of discrete functions. And we've done this, but let's just review this. So remember, the set of all possible x values is the domain. Remember, we also call this the input. So remember that when we are writing our domain, we are writing it as a set of numbers that are in order from least to greatest. So it's our x values here. So hopefully you're able to do these on your own right now. Okay. And then from the table, here is our domain. The biggest thing is to just make sure you write it in order from least to greatest. Okay. We tend to have the most trouble with a graph. Remember, domain is the x, so it's important to just highlight that line. And then we would just find our numbers this way. So you'll see I start at -1, 0, 1, 2, 3, and 4. Okay, here's our line. So I've got 1, 2, 3, 4, -5, -2, 1, and 1, 2, 3, 4. Okay, and then the range is just the opposite. It's the set of all the y values, also known as our output. Luckily, these are already in order from least to greatest for us. Okay, I'm only going to write number 3 because notice we'll have to write that one backwards because we need to put them in order from least to greatest. And then again, usually our most challenging is from the graph. Okay, so our range here, we start from the bottom, so that's at -1, 2, 3, 4, 5, 6. And then -3, 0, 3, and 6. And this next one, -6, -2, 2, and 6. Okay, so hopefully we're good at finding the domain and range of discrete functions. Let's move on to finding the domain and range from continuous graphs. Okay, so we still focus from least to greatest. But when we talk about graphs that are continuous, we have to include all the possible numbers that are not distinct points, so including decimals and fractions. So the way we write that, remember the domain is our x, so we're focusing on the x. It might be good to highlight the x-axis so you know where you're looking for. So here, we look for our very smallest number, and we're not going to find an exact point. So you'll see that this line comes really close to this one. So this is at negative 1, 2, 3. And then we find our largest one. And you can see it's at positive 3. So the way we write this is we say x is greater or equal to negative 3, but less than or equal to 3. So we write it using inequality signs. So let's try number 2. So here, I want my greatest and my least. And then I usually always set it up like this. So here it's at negative 1 to 1, 2, 3, 4, 5. So x is between negative 1 and 5. Okay, again, when we get something that has an arrow, and that's going to go all the way across all these numbers, when we write this one, we say it's infinity. But then it stops right here. So the greatest number it could be is a negative 1. So the infinity sign is just your sideways looking 8. So when we get that horizontal line, that's going to go on and on and on. That's what we write. Okay, and number 4, kind of the same thing. These arrows mean it's going to go on and on forever. And my smallest number is 1, 2, 3. So this is at negative 3. So we say x is greater than negative 3, but it's going to continue on and on. Okay, let's take a look at the range. So the range is our y values. Still the same thing, least to greatest. But this time we're looking at the vertical line and where it would meet. So notice if we were to extend these lines, they would keep going up and down vertically. So that would be the infinity symbol. So x, or not x, because we are in the range. Y, so this is where it changes, would be between infinity and infinity, because they're not going to stop. Okay, this next one, I'm going to look at my least here, my greatest there. So you'll notice now I'm looking where it's going to meet the y axis. So the smallest number here is at negative 2, and the greatest is 1, 2, 3, 4. So this would be between negative 2 and 4. So when we write it in this inequality form, it's going to be between all of those numbers. Okay, so here we see it's going to meet the y-axis at 2, and then it's going to continue on forever. So we have y, the greatest it could be is 2 to infinity. Okay, and our last one, number 8 here. Notice the greatest it'll be is infinity. and it's at 1 for our least. Okay, so hopefully you're getting the idea with that. This can be a little challenging when you first start getting used to it, but it does get easier with practice. All right, so let's focus on graphing discrete and continuous. So graph the function with the domain -1, 0, 1, 2, 3, then identify the range. So the best way to do this is to create those function tables we did. Okay, so our x values are -1, 0, 1, 2, and 3. And we need to find the y. So we are using our function rule to find that. So 2 times -1 is -2, minus 1 is -3. Feel free to check these with the calculator if you need to. The next one, we would get -1, because 2 times 0 is 0, minus 1 is -1. Then we're going to get 1, and hopefully you're recognizing the pattern. So 3, and then 5. So now we would graph them. -1, -3. And because this tells us it's a discrete and we only want these points, we're going to only plot these and we're not going to connect them. 0, -1. 1, 1. 2, 3. 1, 2, 3. And then 3, 5. Okay, so that's the discrete graph. And then it says identify the range. So we would write that as a set of numbers. So we -3, -1, 1, 3, and 5. Okay, let's try another one. Okay, so our domain this time is -2, -1, 0, 1, 2. All right, so our function rule is -x plus 4. That really means -1 times whatever the x is. So -1 times -2 is a +2, plus 4 is 6. So our first number is 6. -1 times -1 is +1, plus 4 is 5. 0 times -1 is 0, plus 4 is 4. And hopefully you recognize the pattern, so we'll have 3 and 2. So we have -2, 6, 1, 2, 3, 4, 5, 6, -1, 5, 0, 4, 1, 3, and 2, 2. Okay, and again, these are discrete, so we're not gonna connect those. And then we're identifying the range in order from least to greatest. So 2, 3, 4, 5, 6. Okay, well, let's take a look at continuous graphs. So this one says our function rule is y equals 2x minus 1, and our domain is greater than 0. So when we set this up, we have our x, our y. We're still going to create a function table, but all of our numbers are going to be 0 and above. Okay, so I'm going to just do 0, 1, 2, 3 to make it easy. So 2 times 0 is 0, minus 1 is -1. 2 minus 1 is 1. 4 minus 1 is 3. 6 minus 1 is 5. So now we're going to graph them. So 0, negative 1, 1, 1, 2, 3, and 3, 5. This time we connect them, and because the domain was greater than 0, we draw our line there. So now to find the range, I'm looking at the vertical here, and our range would be y goes to infinity, and the smallest is negative 1. Okay, let's look at one more example. So we have our x and our y. We're going to create this function table. This time they're saying our domain is greater than 1, so I'm going to have 1, 2, 3, 4. And then our function rule is negative x plus 4. So negative 1 plus 4 is 3. Negative 2 plus 4 is 2. Oh, let me change the color. Negative 3 plus 4 is 1, and then 0. So we've got 1, 3, 2, 2, 1, and then 0. So this time, our graph will look like this, because x is going to continue on. So to find our range, it's going to be the greatest the y can be is 2, and then it'll go to infinity. Okay, feel free to watch this a few times if you're struggling with it, or find other videos to help you, because it does take a little bit to figure this out. So now let's take a look at identifying situations. So why would the cost of movie tickets be considered a discrete graph? Well, because you're not going to buy half a ticket. Okay, there's not going to be decimals or fractions. In the domain. Okay, so the domain would be the number of movie tickets. You're not going to buy a half a movie ticket. Okay, why would points during a game of laser tag be discrete? Well, because you're not going to get a half a point. Okay, so anything that's exact amount, generally money or points in a game of some sort, those would be discrete situations. Continuous is something like time that can go in between. Okay, so temperature of a fish tank during an experiment. Okay, even though this is in hours for our domain, we can still have decimals and fractions. So, because you can have seconds, and then you can go even less than that in partial seconds. So Okay, the same thing with the height of a rocket. You'll see this is in seconds, but we can do like 1.2 seconds. So where would it be in the middle here? So if it can have decimals and fractions, then we consider it a continuous situation. All right, so let's take a look here. Determine whether the situation is discrete or continuous, then state the domain and range. An airplane has implemented a plan to reduce the occurrence of lost luggage. They have observed a linear relationship between the number of months the plan has been in place, and the number of pieces of lost luggage. The airline recording their findings in the table below. Which statement describes the data? So the first thing you got to ask yourself, can this be something that we can cut in half? Can it be discrete or continuous, like in regards to can we change it into partial amounts? So we may look at this one and say to ourselves, well, months could be broken down into weeks and then days. Yes, but can pieces of luggage be cut in half as well? And the answer is no. So this would be a discrete. So now we need to be like, okay, is the range between 1 and 5? Nope, the range is here. We know it's not continuous. And the range is between 450 and 570. So the answer to this one should be C. So let's take a look at the next one. An auto manufacturer has created a plan to reduce brake defects during production. They have observed a linear relationship between the number of months the plan has been in place and the number of cars that are recalled due to defective brakes. The manufacturer recorded their findings in the table below. Which statement describes the table? So again, is this a discrete or a continuous thing? Are we going to break cars in half? No. So it's not going to be continuous. And then we need to see, okay, this is talking about the domain. So the domain is 1 to 5. So we're looking at answer A. All right. At this time, I would like for you to solve these 6 problems on your own. They're already separated into discrete situations and continuous situations. Your job is to identify why that is. So explain why each one is either discrete or continuous. So go ahead and pause the video and complete this one. Hopefully at this time you've paused the video and worked your way through this. So let's see how you did. Okay, if you are confused about anything or have any questions, please make sure you get those answered. At this time, you are ready to move on.